Okay, if we can get through this whole video in one take and last less than 10 minutes, it will be a small miracle, but I'm going to try. The purpose of this video is to just go over some of the vocabulary and introduce some of the topics in the unit on probability. And so let's get started. Okay, first of all, what is probability? Probability is the likelihood that an event will occur. And there's a little bit of, we have to unpack all of these terms, and when we put them together, maybe it will make sense. So the likelihood that an event will occur. So what's an event? Well, an event is a collection of outcomes, all of the possible outcomes of an event. And the outcomes are the possible results of an event. Okay, so let me just use an example for this. I roll a die, and six-sided die, and the different outcomes or the possible results, the event, actually let me back up. The event is the rolling of the die. That's the event. And so the outcomes, it could land with 1, 2, 3, 4, 5, or 6 up. Those different possibilities of what number would be facing up would be the outcomes. The event is, as I said, would be a rolling of the die. And then the probability is what is the likelihood that die, when I roll it, will be a 2. And so the likelihood that it will be a 2, I think we know, is a 1 out of 6 probability. And so these three terms, again, all kind of relate to each other. The event is actually what's happening. The outcome is the possible results that could happen from that event. And the probability is what is the likelihood that a specific, we usually refer to it as a positive outcome, positive outcome will result of, or favorable outcome is another word that we use. Favorable outcome is the likelihood that a specific outcome that we determine will in fact happen. Okay, which leads us to two more topics of theoretical probability and experimental probability. Theoretical probability is the probability if all the results were equally likely. Another way of saying this is the theoretical probability is what we think would happen, what we expect would happen if life was fair. Okay, if life was fair, then if we roll a die 6 times, then we'd get one of the numbers each time maybe. We know that that's not usually the case. Or if you've ever been playing a game and it has a spinner, maybe like Twister or something like that, and there's 4 colors, and you know, in theory, that when you spin that spinner, each color is 4 even quarters. Each color would have an equally likely possibility or probability of landing on the color. However, boards get bent. The spinner is not always, there's a scratch on the thing or whatever the case may be. And we know that when you start playing the game, lo and behold, green ends up getting hit more than the other 3 colors for some reason. So your experimental probability is what actually happens once you do a bunch of trials or a series of trials. Then you find the experimental probability. And again, sometimes, depending on what it is, the experimental probability will be different from the theoretical probability. And so if we spin that spinner a bunch of times, we find out that a lot of times it hits green, and then only a few times it hits blue and red, and it almost never hits yellow, then we would change the experimental probability to indicate what our results gave us. Okay, moving on, we have permutation. And permutation and combination kind of go together. They're very similar except for one very distinct difference. Okay, a permutation is an arrangement of a group of objects in a particular order. You will hear people say the order is important, the order matters. Okay, and a combination is a grouping of objects where the order is not important or doesn't matter. So I'll give you an example. If I am going to pick my 3 favorite songs on a CD, and I want to play them with my first, I'm going to play the CD randomly, right? And then I could find out the permutation of that my favorite song plays first, and my second favorite song plays second, and my third favorite song plays third. That would be a permutation because I want my favorite song to play first. I don't want my favorite song to play second. I want my favorite song to play first, my next favorite song to play second, and my third favorite song to play third out of 15 total songs. I would have to find that out using a permutation. The order matters. A combination is a grouping of objects where the order is not important. So using the same example, if I were to say what would be the probability, or wanted to calculate the probability that if I put shuffle on my iPod and on that CD and it shuffled the songs, what would be the probability that the first 3 songs that are played are my top 3 songs? In other words, if the order doesn't matter, I still want those 3 songs to play. But if my third favorite song is first, and my second favorite song is second, and then my favorite song is third, it doesn't matter because I'm still hearing those 3 songs instead of the other, 12 that I don't like as much. So permutation, combination. Interestingly, your combination lock, if you have a combination lock, that's not really a combination according to probability terminology. Because if your lock and combination is 17, 24, 6, if you try to put in 24, 6, 17, it will not open. Okay, so a combination lock is, in fact, really a permutation because the order matters. Now, if you go to the Subway and you order a sandwich and a drink and a side of fries, right? Or if you order the fries first and the drink second, and whatever sandwich you wanted third, it doesn't matter because they're all going to come on the same plate. And as long as you get the sandwich you want, and the drink you want, and the size fries you want, then you're happy. So that would be a combo meal. Okay, that's a combination. The order you get them in doesn't matter, but you don't want somebody else's sandwich. Okay, so anyway, we'll do some more examples when we talk about those more specifically, but that's the general idea. Factorial notation should be here. Factorial notation looks like this. 5, and then the factorial sign is exclamation point. And basically what that means is it's just a way of short writing in a condensed form. 5 times 4 times 3 times 2 times 1. That's factorial notation. Then factorial notation for the product of a number times the number minus 1, the number minus 2, the number minus 3 until you get to 0. Okay, obviously you don't multiply it with 0 because then you'll always get 0. But 5 factorial or 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Okay, you use that in probability. By the way, just a side note, 0 factorial is 1. It's kind of an exception to the rule, so make a note of that 0 factorial is 1. It's not 0 if you have to divide by 0 factorial. Okay, and then last but not least, the counting principle says the product of a number of ways 2 or more events can occur. So I'm going to flip a coin and roll a dice. Okay, so if I flip a coin, there's a 1 and 2 probability that I will get a heads. Okay, so I want to know what's the probability of I'll get heads, and it will be a 6. Okay, so the probability of heads is 1/2. The probability that it will land with a 6 side up is 1 out of 6 because it could be a 1 or 2 or 3 or 4 or 5. So the probability that I flip a coin and roll a 6 is a 1 in 12 chance. You just multiply those things together. So anyway, when we get to the specifics of all those things again, then you'll hear some more detail. But that's the terminology and some of the vocabulary we'll be using. And I hope this wasn't too fast and made sense to you. And sorry about the glare, but if you have any questions, please ask them in class. Thank you for watching.